So next topic is pure rotational Raman spectra. Before going into this topic, if you want to understand this topic in a better way, you first of all you have to read about the Raman scattering. So I have made a video. I gave the link of my video in the description. You can watch that video, then you can go for this. Okay. And for pure rotational spectroscopy, we have two separate molecules for linear molecule and for symmetric top molecule. We discuss these two things today, and we'll solve some of the problems on this also. First we'll go for the linear molecules. So the selection rule for linear molecule, delta J equals to 0 and plus or minus 2. So you don't need to by heart it, you just you know that moment of inertia, how it changes when we have a linear molecule. Imagine that we have a like this AB molecule. So we have three axes here, x axis, y axis, z axis. Okay, so the how we can represent moment of inertia here, Ix equals to Iy, and it's not equals to Iz, right? So from this this we can calculate from here, because here only in one direction. See, so imagine that this is A, this is B, and this is B. When we change this way only, there is a some change. So from here we can make out that there is a 2 degree of freedoms are there. So this gives 1 degree of freedom, and this can give another degree of freedom. So because of that we have a plus or minus 2 for the linear molecule. So when we have a 0, that means there is no rotation, and the molecule is constant, and there is no change in the energy of proton, no change in energy of photon. So when we are talking about Raman spectroscopy, so like there we have two concepts, elastic collision and inelastic collisions. Okay, elastic collision means we have a proton. Okay, so we are hitting this proton with some energy of h nu, and before that the energy of this one, imagine that 2 kilocalories. Okay, after hitting with proton also, the energy, the emitted proton, this is the proton, this is the incident proton, and this is the emitted proton. Okay, the energy of incident proton and emitted proton is same, that is called as elastic collision. And for inelastic collisions, further we have two things, Stokes lines and anti-Stokes lines, and that those things I have explained in my video. You can refer that video. Okay, and here that delta J equals 0 means there is no change in the rotation, no change in the energy of proton. So no change in the energy of proton means we can consider this one partly as a elastic collision. Okay, so the energy, the principle which we use to calculate energy is dj equals to bj into j plus 1 centimeter inverse. So this is the principle which we use to calculate the, we calculate energy terms by using this principle. And now then we can see a delta J equals to plus or minus 2. Okay, so we can also say this one, we can also say when delta J equals to 0, we can say that the polarizability changing twice. No, we cannot say that. The rotation is 2 times. We can say that 2 times rotations are happening. 2 times rotations are happening here. Okay, so that means, it's going from 0 to 2, right? Now the energy difference, the total energy difference, how we will calculate? E j plus 2 minus e j. Okay, so this we can write as a, this one we have for this term we can write like b j plus 2, and for 2 we can write j plus 2 plus 1 minus, for this same term come here, bj into j plus 1, this term comes here. And if you simplify this one, we'll get a b 4j plus 6 centimeter inverse. So this is very important, you have to remember this principle. So many times problems have been asked on this principle. Okay, so now we'll see the spectrum, how the spectrum looks like. So this will be 1 0 1 2 3 4 5. Okay, so we know that delta j equals to plus or minus 2, right? So the first transition will be from 2 to 3, 2 to 0. The second transition will be 3 to 1. Third transition will be 4 to 2, and fourth transition will be 5 to 3. Okay, and here the transition will be upside. Here in this case it will be upside, and the selection rule for these transitions are delta j equals to plus 2. The selection rule for these transitions are delta j equals to minus 2, because these transitions are happening from the higher energy level to lower energy level, means there is some release of energy in this case. Because of that we have a positive term here, and these transitions are going from the lower energy term to higher energy, lower energy rotation, lower you can say, yeah, lower rotational energy level to the higher rotation energy level. So because of that it requires some energy, so for that the delta j equals to minus 2 for this, and this we can write it as a, and this will be 0, this will be 2b, this will be 4b, and this will be 12b, and this will be 20b, and this will be 30b. So now how you can calculate these things? See, the principle what we have here is, to calculate energies we need to use this principle. Okay, and easy means like when you're having the transition from here to here, that time you will be using this principle. But when you're calculating these things are nothing but e0. E0 means b into 0 into 0 plus 1, that will be 0. Okay, next e1 means b into 1 into 1 plus 1, that will be 2b, and e2 means b into 2 into 2 plus 1, this will be a 6b. e3 means b into 3 plus 1, this will be 12b, and e4 means 4b into 4 plus 1, that equals to 20b. So like that. So when you're calculating these energy levels, you have to use this principle. Okay, sorry, this is 6b. Okay, now you can when you're talking, when they have given the transition, imagine that here this is from the, we can say that this, you can say this is from the et to e0. Okay, and that time when they are asking energy means a transition, that time we have to use this energy level. Okay, now you have seen in the Raman spectroscopy, this is the elastic correlation, or we can say relate scattering. Okay, and this side we have Stokes line, this side we have anti-Stokes line, like that. So here also we have the same kind of spectra, and this will be this will be like this, right? And here it will be, and here when we are calculating this spectra, means when you're drawing, when you're plotting the spectra, so we can say this is the relayed scattering. Okay, and what is the negative? Negative means this is Stokes lines, and positive means this is anti-Stokes lines. Okay, now here the energy, this the spectra looks like this, and then like this, and this spectra is very important, like this. And the energy of this is the energy of this one is 6b. So how we will calculate this one? Because this is the we can say that this is the transition which is going from the 0. Okay, now we have a principle that energy equals to b 4j plus 6 centimeter inverse. So now keep a 0 here in place of j. This will be 4 into 0 plus 6b. This will be 6b. Okay, that 6b is coming here, and the next level will be, just keep 1 here. 4 ones are 4. This will be 10b. For next one, b 4 into 2 plus 6, that equals to 14b. And next we have 4 into 3 plus 6. 4 2s are 12. 12 plus 6, 18b. The next one will be, I think 4 4s are 16. 16 plus 6, 22b. And the same level, same energy levels comes here, 18b and 22b. Okay, and you don't need to by heart this diagram. You can, it's very simple. Just remember that you have to take a only lesser energy level. Here the transition is going from 0, so we have taken 0. But in this case, anti-Stokes line, the transition is coming from higher to lower. Always imagine that in both the sides we have to use the lower j value to calculate these energy levels. Okay, and now the difference between these two and these two is called as the Raman shift. Raman shift. So this we can represent as nu ex plus or minus b 4j plus 6. So why we use plus or minus? So we know that this is the negative region, this is Stokes lines, and this is the positive region, this is anti-Stokes lines. So we have plus and minus. For that, the Raman shift can be plus or minus. So if they ask for Stokes lines, then it will be ex plus, sorry, minus b 4j plus 6 for Stokes lines. For anti-Stokes lines, it will be plus. Okay, so this is about this for linear molecule. And the difference between the this relate left, the difference between the first line difference will be a 6b. So on this many problems have been asked, like what on basis of this. So we will solve those problems later. So till now we spoke about the linear molecule. Now we'll speak about the symmetric top molecules. So here I forgot to tell that the first transition, the difference between the relayed scattering and first Stokes line or first anti-Stokes lines will be 6b, and any two Stokes lines or any two anti-Stokes lines, the energy difference will be 4b. Okay, these things are useful while doing some problems. So this is about the linear tops. Next we will go for the symmetric tops. Symmetric top. So symmetric top also important. The selection rule for symmetric top, delta j equals to 0 plus or minus 1 and plus or minus 2, and delta k equals to 0. So this is the selection rule. But for linear molecule we have a selection rule, delta j equals to 0 plus or minus 2. but for symmetric top we have this kind of selection rule. So here why we are taking plus or minus 1 also, because for symmetric molecule, when you take a symmetric top molecules like benzene, here the rotation, the what is the minimum, what is the requirement for the Raman spectroscopy? There is a change in the polarizability. For symmetric top molecules, two moment of inertia are same, okay, only one moment of inertia is different. And here the polarizability change will come when we rotate this end, we can say that end over end rotation. So end over end rotation produces the polarizability, and that is possible through only one moment of inertia. So because of that we have a plus 1 also here. Okay, and here we can if we can write these lines like this. So when we have a plus or minus 1, we can say this as R lines. If it's minus 1, this is R Stokes lines, and if it's plus 1, R anti-Stokes lines. And similarly we have plus or minus 2, these are S lines. When it's minus 2, that is called S Stokes lines. When it's plus 2, that is called S anti-Stokes lines. Okay, and here we have two principles to calculate energy. Is A equals to B sorry okay, B for J plus 6 centimeter inverse. This is only for delta J equals to plus or minus 2. Okay, when we are talking about delta J equals to plus or minus 1, that time the energy we calculate to be J plus 1 centimeter inverse. So this is the energy. This way we have to calculate energy. Now we will see the spectra. And the energy gap between each energy level is same only. I am not writing properly. 0 1 2 4. So according to this one, this will be 0 2b 6b. Substitute these things in this value as 12b, and this will be 20b. Okay, so here two kinds of transitions are possible. This is plus 1 and this is minus 1. Okay, and this also possible here. This we have already discussed for linear molecule. Same concept you can apply here also. So here I am talking about only about this plus 1 and minus 1. And this portion is the elastic collision, we can say Rayleigh scattering. And here this will be a like this. This will be 2b 6b. Means like we have to calculate by using this principle. Okay, so this is the 0 2 into b 0 plus 1, this equals to 2b 2 into b 1 plus 1, this will be 4b 2 into b 2 plus 1, this will be 6b 2 into b 3 plus 1, this will be 8b 2 into b 4 plus 1, this will be 10b, and this 8b 10b, and then it will be I think 12b. Okay, now here also 2b 4b, this is 4, sorry 2b 4b, this is 6b, this is 8b, this is 10b, this is 6b, 8b and 10b. So these are the S lines, these are the sorry, you cannot select that. Oh, wait. So here we have two selection rules, delta j equals to plus or minus 1 and plus or minus 2, and this is for the plus or minus 1. And when you are talking from here to here, so this will be S line, and when you are talking about these two, this will be R line. Okay, so for symmetric top molecules we have both selection rules, and for when selection rule delta j equals to plus or minus 2, that time when j equals to 0, that will be a 6b. We have seen already this one, then 10b, then 14b, then 18b, like that it will come. So the S line will start from here. So this transition to this transition, this is the S. Okay, and this will be R, because the first transition for S, first transition when we have a delta J, that is equals to, I have explained before, that is 6b to 10b, right? That's why this we call it as S line, and this we call it as a R line. And this is the this is the positive place. We can say positive means R anti-Stokes lines and S anti-Stokes lines, and here this transition will be minus R, and from 6b to 10b this equals to minus S. R Stokes lines and R Stokes S Stokes lines. So don't get confused. For symmetric top molecules we have selection rule delta J equals to 0, plus or minus 1 and plus or minus 2. Okay, so here the transition from 0 to 2b to 4b, that means 0 to 1, this comes under a R line. Okay, because here changing here the selection rule delta J equals to minus 1, so because of that minus 1 means R Stokes lines, this will be R Stokes lines, and this will be the selection rule here is delta J equals to plus 1. Plus 1 means here we wrote here plus 1 means R anti-Stokes lines. Okay, and then minus 2 means Stokes lines, S Stokes lines. So the difference between here to here is minus 2, so that's why we call it as a minus S Stokes lines. And plus 2 means anti-Stokes lines, the difference between from here to here is plus 2, so because of that we call this as a S anti-Stokes lines. So then next thing, when we have a selection rule delta J equals to plus or minus 1, the first energy and the any level you take, the energy difference will be 2b. So when we have a delta J equals to plus or minus 2, in that case here the energy difference will be 6b, and all other energy difference will be 4b. I have explained this one before, that we can see here also. We can see that first energy level means the in case of delta J equals to plus or minus 2, the first energy level will be 6b. So the energy difference between this Rayleigh scattering and this 6b equals to 6b, and then 6b 10b equals to 4b. Okay, so this is about the Stokes lines, this is about the symmetric molecules and asymmetric molecules. And next we'll discuss some problems. Before that we have a small concept that till now we have spoke about the rotational Raman spectroscopy. Now we will talk about the vibrational Raman spectroscopy, then we will go into the problem altogether. Is a vibrational Raman spectra. So vibrational Raman spectra means there should be change in dipole moment as well as polarizability. Okay, and what is the selection rule here for vibrational spectra? That is delta nu equals to 0, plus or minus 1, plus or minus 2. Okay, and when delta nu equals 0, that time there is, it's not vibrating, molecule is not vibrating, not vibrating. So when it's a plus or minus 1, that is a this is called as fundamental vibration, and the energy of fundamental vibration we calculate by using a W minus 2WXC. And then for Raman shift, like if we want to calculate the Raman shift for fundamental band, the Raman shift will be nu x plus or minus W minus 2WXC for fundamental vibration. So it's very simple. Directly we'll go into the diagram. It will be like this. So here you need to remember only few points, that is equals to, this is the Q band and this is the O band, S lines. Okay, so for here Q band is a forbidden band. So why a Q band is forbidden means, like here in this case delta J equals 0. For Q band, the delta J equals to 0, and this will be minus 2 and this will be plus 2. Okay, delta J equals 0 for this, and delta nu will be plus or minus 1. Okay, now here vibration is changing, but the rotation means like the rotation is not changing. Okay, so that, but vibration Raman spectra means what? They should be changing the vibrations as well as the rotations. Sorry, this is the rotational vibration Raman spectra. Okay, I forgot to include here rotational. So this is rotational vibration Raman spectra. So here the selection rule is delta nu equals 0, plus or minus 1, plus or minus 2. So this I have explained in detail. And here, so rotational vibration Raman spectra will be observed only when there is a change in the rotations as well as vibrations. Then only we will observe, otherwise we cannot observe. So for the Q band, the delta J equals 0. So in that case we are not observing the rotations. So because of that, the Q band is forbidden band, and the O and S bands are allowed bands. The energy change we can calculate only for the O and S band. So the energy change we can calculate like this: delta J equals to, if delta J equals plus 2, that is for S band, that will be delta E equals to W plus B 4J plus 6. This is for S lines. And when delta J equals to minus 2, and that case delta E equals to W minus B 4J plus 6. So this is for the this is for S line, and this is for Q line. So this is not the, it means like here we have to remember only two principles, and these two principles, if they ask problems, so we have to remember these principles to solve the problems. I hope it's clear. If you have any doubts, you can ask in a comment box, and on all these three topics I will be uploading one more video which contains mainly only problems.